Okay, so this is the same problem that we did. We're using graphical method. The name of the file is, there is the name of the file, 01-product mix1. Now first thing I'm going to do is to look at the input and do some color coding like what we did in chapter 2. Okay, so we are given the cost of labor, okay, assembly labor cost. So all the inputs I'm going to use that background. And then labor hours needed, okay, 5 hours and 6 hours for the two models, and testing 1 hour and 2 hours. We used this in the graphical method. Now we have cost of component and selling price. Yeah. We used the unit margin of $80 and $129 in the graphical method. Now these are the information that is given in the textbook. So we are now going to have to compute the unit margin ourselves. So we have the selling price. Now we have the labor required and the labor hours needed. So we can now compute the cost of the unit, and then the difference is our margin. But before that, let's give names to these two cells. Okay. So cost of labor for basic is that times cost per labor hour, okay, plus labor hours needed for testing times the cost of labor hours for testing. Okay, so that's your labor plus components. So that's our total cost for basic. Now if you take the unit price and subtract the unit cost, this gives you $80 profit. And this is what we used in the graphical method. Now if you copy these two cells over there, then you get the unit margin for XP, which is 129. Now we have production plan, and this is where we will, I'm going to put a border. Okay. So this is the range where we want to determine how many units of basic to produce, how many units of XP to produce. So these two cells will now represent our decision variables, or in other words, X sub 1 and X sub 2. Okay, so we are not going to enter the values ourselves, and we're going to be using solver, Excel solver, to find values for these two cells. This is the maximum number of units that we will be able to sell, and that's again input number. We are given that, and we want to make sure that how many units we produce of basic, okay, is less than or equal to 600, and XP is less than or equal to 1200. Now we have the hours used constraint. Okay. The hours used constraint is how many hours of assembly labor we'll need to produce these two products. Okay, let's give name for that. And let's give names for the labor hours needed per unit also. Okay. So now when you use some product, remember some product that we did in chapter 2. Okay. Now these are the hours needed for assembly per unit, and these are the number of units that we're going to be producing. So that will give us, this will give us the hours that we will be using of assembly, and another sum product of labor hours needed for testing and units produced. This will give us the hours that we will use from testing, and these two should be less than or equal to the hours available. So these are the constraints. Now let's look at the profit that we'll be making. So we make $80 profit per unit times how many units of basic we will make. So that will give us the profit for basic. You copy that over, that will give you the profit we'll make of XP, and if you add the two, then that is the total profit we will make, and that is our objective cell. So we will give a different color for that. How about that? And this is what we want to maximize. Okay. So this is our model. We have set the model up now. Next is to run solver to find the solution. So model is done. We have to find the solution.